All right, let's talk about rational expressions. I know, they can look pretty intimidating when you first see them, with all those variables and fractions, but trust me, they're one of the most fundamental concepts in algebra. Over the next few minutes, we're going to build a complete toolkit step by step to help you absolutely master them. So what even is a rational expression? Well, the fancy definition is the quotient of two polynomial expressions. But really, all that means is it's a fraction with a polynomial on top and another one on the bottom. Let's make it real. Imagine a pastry shop. They've got fixed costs, let's say $280 for rent and utilities, and it costs $9 in ingredients to make each box of pastries. So the total cost is 280 plus 9 times x, where x is the number of boxes. Now, if you want to find the cost per box, what do? You just divide the total cost by x, the number of boxes, and boom, just like that, you've got yourself a real-world rational expression. Okay, so here's the big secret, the one thing that's going to make all of this click for you. If you already understand how to work with regular fractions, you are honestly 90% of the way there. We're going to be using the exact same rules, adding, subtracting, the whole shebang. We're just swapping out simple numbers for polynomials. That's it. So here's our game plan for today. We're going to start with the single most critical skill, simplifying. Once we've got that down, we'll move into multiplying and dividing, which is pretty straightforward. Then we'll tackle the part that can be a little tricky, adding and subtracting. And to finish it all off, we'll have a final challenge that puts all your new skills to the test. Okay, let's jump right in with our first and, I'd argue, most important tool, simplifying. Seriously, if you can get really good at this one skill, everything else we do today is going to feel so much easier. And if there is one thing you remember from this entire explainer, I want it to be this little mantra right here. When in doubt, factor it out. Factoring is like the master key. It unlocks almost every single problem you'll face with rational expressions. So how does it work? It's actually a super simple two-step process. First, you look at the top and the bottom of the fraction, and you factor everything that can possibly be factored. You break it down into its building blocks. Then, you just look for any identical factors, any of those building blocks that are the same on the top and the bottom, and you cancel them out. Why? Because anything divided by itself is just 1. All right, let's get our hands dirty with an actual example. We've got x squared minus 9 on top, and x squared plus 4x plus 3 on the bottom. Now, looking at it like this, it seems kind of stuck. There's not much we can do, right? But what happens when we use our magic phrase and factor it out? The whole thing just opens up. That numerator, x squared minus 9, you might recognize that as a difference of squares. It factors neatly into x plus 3 times x minus 3. And the denominator, that trinomial, factors into x plus 3 times x plus 1. Ah, now we can see what's really going on. And this is the magic moment. Do you see it? We have a common factor of x plus 3 sitting on the top and on the bottom. And since anything divided by itself is 1, we can just, poof, cancel them out. And that leaves us with our final, much simpler answer, x minus 3 over x plus 1. Much cleaner. Now, this is a super important question, and it's a trap a lot of people fall into. Let's go back to the original problem for a second. Why couldn't we just look at the x squared on top and the x squared on the bottom and just cancel them out? It seems tempting, doesn't it? The answer is a huge, absolute no. And you've got to burn this into your brain. You can only cancel common factors. That means things that are being multiplied together. You can never, ever cancel individual terms, things that are being added or subtracted. That's the whole reason we have to factor first. It turns the expression into things that are multiplied. Okay, you with me? Let's move on to our next set of tools, multiplication and division. And I've got some great news for you here. This works exactly like it does with the regular, everyday fractions you've been working with for years. When you're multiplying, it's a pretty straightforward deal. Step 1, and this is going to sound familiar, you factor everything you possibly can. Then you just multiply all the numerators straight across the top and multiply all the denominators straight across the bottom. Finally, you look for any common factors you can cancel out to simplify your final answer. And what about division? Even easier. You just have to remember that one little trick from back in the day, keep, change, flip. You keep the first fraction exactly as it is, you change the division sign to a multiplication sign, and you flip the second fraction upside down. And just like that, you've turned it into a multiplication problem, which you already know how to solve. Okay, deep breath. We're now heading into what most people find to be the trickiest part of all this, adding and subtracting. But there's a key that unlocks it.
And that key is understanding something called the least common denominator, or LCD.
So what's the deal? Why is this so different? Why can't we just add the tops and add the bottoms like we did when we were multiplying?
Well, think back to regular old fractions. You can't just add 1/2 and 1/3 and get 2/5, right? It doesn't work. You have to find common ground first. You need a common denominator. Well, it is the exact same idea with rational expressions. You can't combine them unless the denominators, the bottoms of the fractions, are identical. So this least common denominator, or LCD, what is it really? It's just the smallest possible expression that both of your original denominators can divide into cleanly. The way we find it is by factoring each denominator and then multiplying all the unique factors together.
Okay, here's the 5-step playbook. First, factor the denominators. Second, figure out the LCD. Third, and this is the key step, you multiply each fraction by a clever form of 1, whatever it takes to make its denominator match the LCD. Fourth, now that the denominators are the same, you can finally add or subtract the numerators. And last, you simplify the result if you can.
All right, you've made it. It is time for the capstone challenge. This is where we get to bring all of our new tools together, simplifying, adding, dividing, and see them work in harmony to solve something that looks really tough.
Okay, take a look at this thing. Yikes. It's called a complex rational expression, basically a fraction inside of another fraction. And yeah, it looks like a total mess. But here's the thing. You are completely equipped to handle this. You have every single tool you need.
The secret here is to not panic. We just break it down. First, let's just focus on the numerator, that y plus 1 over x. We can treat that as its own mini problem. It's an addition problem, right? So we need a common denominator, which is just x. We rewrite y as xy over x. Now we have xy over x plus 1 over x. Since the denominators match, we can combine them into one clean fraction, xy plus 1 all over x. See, we've already simplified part of the problem. Okay, so our crazy problem from the beginning has been tamed. It's now our new numerator, xy plus 1 over x, being divided by our original denominator, x over y. Hey, this is just a division problem, and we know exactly what to do. We keep, change, flip. We keep the top fraction, change to multiplication, and flip the bottom one to be y over x. Now we just multiply straight across. On top, we get y times xy plus 1. On the bottom, we get x times x, which is just x squared. And that's it. That's our final simplified answer. So there you have it. That's your complete toolkit for making sense of rational expressions. We've tackled how to simplify, multiply, divide, add, and subtract them. And listen, this isn't just about passing your next algebra test. These skills are the foundation for figuring out all sorts of complex problems, whether it's in engineering, physics, or even finance. The ability to take something that looks complicated, break it down and simplify it, that's a genuine superpower. And now,